Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials on any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com.
Okay, it is also set of machines or nodes which will run the workload. Okay, which will run the workload or application replicas. Okay, so what will happen? So as I'm mentioning, the control plane is nothing but a set of machine which will be responsible to manage the cluster. So all those admin level or those commands that you run while you want to manage your cluster, like how many nodes should be there, which node should be operational, where you want to send the pod, how you want to create the application, all those things will be done on your control plane. But when I'm saying the worker plane, the sole purpose is to run the application. So that means the worker plane will run all those application as a containerized image. Okay, so as we are defining these two things here, so as you can see inside this particular thing, uh, here you will be able to see there is something called as master nodes, and you can see something like as a worker node. Okay, so these two are which are in green color are worker nodes, and this yellow color is nothing but your master node. Okay, so as I am trying to explain you that worker node, the master node is nothing but your control plane only. So master, it is also called as master nodes. Okay, and it is known as worker nodes. So a name itself suggests that master node will be performing some administration task, and worker node means running the application. So you can see that this is the basic overview of the Kubernetes architecture. And now here there is a difference between the component that each of your master node or worker node is using. Okay, each of your master node or worker node is using. So before moving ahead, we will be discussing all those things in details, like what is this API server. So for now, let's understand that master node has a 4 components. As you can see, the first one is API server, the second one is controller, the third one is scheduler, and then you see something like a database, which is a key value store etcd. So these are the 4 main components that a master node is using. And then we have the worker node, and in worker node we have kubelet. So we'll be discussing all those things. What is kubelet, what is API server, what is controller, scheduler. We will discuss everything. And now you will be able to see that pods are running on the worker node. So these pods are nothing but your application pods. After that, it has also has a network runtime. That means like something like Docker. So this network runtime is also required on master also. So we'll also discuss that thing. But the majorly the 4 component that are on master node is API server, controller, scheduler, and then key value store of etcd. The similar way in worker node we require kubelet and we require kube proxy, and then application pods are running on this particular thing. Now you might also observe here the developer is working on master node. So that's what I mentioned. When you want to fire some administrative commands, you will have to fire that on like you will have to communicate with the master node, basically master node and API server. And if you are an end user, so what is end user? So let's say you have some application for your organization. So let's say it is google.com is the application for your organization. So this end user need not to know where this application is running. So the sole purpose of this user is to reach google.com. So they don't care like where that application is running, right? So our pod is running on worker node. So these users will be communicating directly on with your worker nodes, or in that case, to be more specific, we'll be using some load balancer that will redirect the traffic in the backend to the respective pod. Okay. So this is the basic Kubernetes architecture or the overview of your Kubernetes architecture. we'll discuss each and every component in details. But before that, let's go ahead and learn about more about what is the understanding the Kubernetes concepts. Okay, so what happens when you spawn up the pod inside Kubernetes? We'll see that. Okay, so before that, let's go ahead. So I'm talking a lot about pod, like I'm saying pod a lot many times, right? So let's understand first what is a pod and what is the difference between container and pod. Okay, so let me just open a new fresh window here. So now we are discussing what is pod. Okay, we are discussing what is pod. Okay, so basically the control plane have four components, and what are that? So first one, as I mentioned, API server. Then you have scheduler. Then you have controller. Okay, and the last one is your etcd. What is etcd? It is just like you can think of it as a database where all the data of your cluster will be stored. Okay, so we'll be discussing more about this, all those components, and what is the worker plane components. So these are like major components. Okay, following major components, worker plane components. So what is that? So okay, so in worker plane component, what we are discussing is one is kubeproxy. So I'll be explaining that, and another thing is kubelet. Okay, now to tell you more precisely, this two kubeproxy and kubelet is mandatory for all the nodes, and it also runs on control plane also. But since I'm saying a major component, so that's why I'm not writing here. But otherwise, these two components, kubeproxy and kubelet, are also available on your uh, master node also. Okay, so it is not like that that your master won't be requiring this thing. Okay, but before writing these things, let's understand what it is, then you will get more clarity on that. Okay, so now once we have learned about the basic architecture, let's now learn about what is pod. Okay, so as I'm mentioning, what is pod? So we are talking about pod. So what is a pod? Okay, so first of all, pod is nothing but a container or a group of container running to achieve the same goal. Okay, so what is that? So I'm saying pod is nothing but a container or a group of container. Okay, so what is that thing? So consider in Docker containers, you are referring every instance as a container, right? In Docker containers. So pod, as I'm mentioning, pod is nothing but container only. Okay, pod is nothing but a container only.
Hey viewers, our Master in DevOps engineering program can help you to hone the skills necessary to succeed in high-level DevOps positions. So, what are you waiting for? Enroll now and earn certification that show you are keeping pace with today's technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
The only difference here is pod is the smallest entity in Kubernetes, and we do not directly talk with containers. containers, but with pods. So as I mentioned, this pod is the smallest entity inside your Kubernetes cluster. So whenever I'm saying pod, so that means I will only communicate directly with the with pod. Like, so as I'm mentioning, pod can be one container, right? Let's say this is one container. So C1 container C1. So pod can be container. Then again, what I'm mentioning, pod can be also set group of containers. That is also what I'm mentioning, right? So let's say if there are multiple containers, okay, and if those are achieving some same goal. So what do I mean by same goal? Okay, what do I mean by same goal? So these are also the containers that are running, and this is one single container. So even if there is a single container, we will call it as a pod. And if there are multiple containers, but those containers are running together, like they have some common goal, okay, they have some common goal. So for example, if there is a one application, and an application requires you to have one proxy, okay, and now that proxy is provided through your another container. So those two containers are performing the same job. Or in other terms, let's say you have some web application. So in web application, definitely there will be two components available. So one is web server and another is DB server. So web server, let's assume web server is running inside as a one container, and DB container is DB service is running as another container. Now the job of these two container is to provide one web application, right? So these two containers are working together to achieve something. So they have common motive. So that's why I'm calling them as a pod. Okay. Now what is the difference between this particular thing here and in container? So when I'm saying pod, the IP will be given to only this particular group of containers. So that means what I'm saying, only one IP will be given to this particular three containers, and another IP will be given to this particular one container. So what I am trying to say is, when I'm saying about pod, or when I'm saying pod as a single container, so this single container will also have only one IP. And when I'm saying pod as a set of container or group of container, it will also have only single IP only. So this all three won't have the three different IPs. Because why? Because in Kubernetes the smallest entity is pod, and I will talk to pod by IP address, right? So if I'm talking with IP address and I'm saying this is also pod and this is also pod, so pod should have a single IP. So that means inside these containers will communicate with each other. That is fine, but they won't have different IPs. Okay, they are managed only with a single IP. So we'll see in later stages. We'll see how we can communicate with this inside containers. But for now, pod is nothing but container or uh, group of container running to achieve the same goal. And pod is smallest entity in Kubernetes, and we do not directly talk with containers but pods, right? And one more thing that we learned here, pod have single IP even when there are multiple container inside your pod. Okay, so that means, so you might get confused here, that you might think that can we assign multiple IPs to the pod, right? So that is possible. Like assume it like that you can assign multiple IPs for a pod, but all those IP will be redirected to this complete group. So we are not directly talking with the container. We will talk with the pod only. And then you might have different IPs. Like you can configure like that to have different IP. So now assume this thing like that. So if you have the understanding over virtual machine, so this is one virtual machine. Okay, this is one virtual machine, you can think of like that. And this whole is another virtual machine. Okay, so as you might be aware that virtual machine will have some IPs, right? But the applications those are running inside your virtual machine need not to have any IP addresses. So similar concept is followed in the pod also. So that's what clears a point about pod. Okay, pod have a single IP. That means yeah, pod have a single IP even when there are multiple containers. That is containers. Uh, that is, we don't directly communicate with containers using IP. Okay, so that is fine. So I have explained like what is the pod here. So let's go ahead and let's now understand what happens when you spawn up a pod inside your Kubernetes. Okay, so just open this for you. So okay, so we have seen the Kubernetes architecture and we have seen the control plane, but we need to discuss more about the components inside your control plane. But yeah, more or less like we'll discuss it in later sections. So you can see that the kube API server is there, then kube scheduler is there, then control two type of controllers are there, kube proxy is there, and additional services, and kubelet is also there. So as I mentioned in the notes, I clearly had mentioned.
Hey viewers, trying to get into DevSecops? Enroll for our DevSecops certified professional programs and earn the certification that shows you are fit for these technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
That your control plane will also have the kube proxy and kubelet. Okay, so that is mandatory, and you will understand why we are using that once we move ahead in the session. So now let's go ahead and let's understand some basic concepts of your Kubernetes cluster. So what is the basic concept here? So first thing, when I'm saying the Kubernetes cluster is a set of nodes, or control plane is a set of machine or node. So first thing we have to understand here is what is node. Okay, what is node? Okay. What is node? So node, what is node? So node is nothing but a virtual machine or virtual machine instance, or you can say physical machine instance. So it can be anything, depend upon your configuration. You can create the machine. So node is nothing but your machine that is participating instance, that is participating inside cluster. Okay, so it is part of cluster. So what is node? Node is nothing but a virtual machine instance or physical machine instance, whatever the infrastructure that you are using, but that is participating inside a cluster. So that's what we call as a node. Okay, so what does this cluster node will have? So as I mentioned, every node will definitely have this component. So first is kubelet, second is kube proxy, and then we have some container runtime like Docker and all, and then we have some containers. So that means we have some pods. Okay, we have some pods. So every node will have that. Okay, every node will have that. So first thing we discuss here, you just need to understand what is node. That's it. After we discuss more about kube proxy, I'll come back to this image again and I'll explain what is happening over there. So node we have covered, pod we have covered. Now what is the service? What is the service? Okay, let's learn what is the service. Okay, so let's learn what is the service. Okay, so service is nothing but the abstraction layer required to manage the pods. Okay, so what is that? What is abstraction layer? What do I mean by abstraction layer? So this service don't have the physical interface, but still carry the IP. So you might be aware that whenever we need to assign some IP, so we need to have the network interface for that. But this service is does not have that physical interface or any interface, but it still carries this IP. So this IP is like a virtual IP that we are assigning just for the communication purposes. So in the back end, it uses the kube proxy to communicate. So that's why I'm calling it as a abstraction layer. So service is nothing but the abstraction layer required to manage the pod. How to manage, or I can say load balance the pod, load balance the pod, load balance the pod. Now what happens whenever I'm saying that service load balances the pod, right? I'm saying service. So that definitely brings this point that let's say this is a service and let's say these are the pods. Okay. Now whenever I'm saying the service load balances the pod, so what happens? Let's say there is one user, end user, okay, end user. So assume something like that. This is the end user, and he is hitting some www.google.com. So what will happen? This particular traffic will hit on some load balancer, okay, some load balancer, okay, and now load balancer. And now this load balancer is nothing but your cluster load balancer. So it will this end user is typing some www.google.com, it will hit on your load balancer. Now internally this load balancer then sends this traffic to the service, okay, sends this traffic to the service, okay, and not to the pod, okay. So what happens, this service then manages the pod, then service sends the traffic to the pod, okay. So service then sends the traffic to the pods. So how do this thing happens? I mean, the end user is hitting. So this part we can cover later also. What is this load balancer, cluster load balancer? But for now, you just understand this end user is putting www.google.com. So it is hitting that request on load balancer, and now load balancer will, the cluster load balancer will forward this request from end user to the service. Okay. Now this service will transfer the topic to the backend pod. Now how this service is gonna understand that this pod I have to transfer the request. I mean, are these all pods are replicas of each other, and how to forward the traffic? Okay, so there is one very important concept that is called as labels in Kubernetes. So labels in Kubernetes. So what happens in Kubernetes? Everything happens on the label level. Okay. So let's think of like that. I'm giving one label equal to A equal to 1. Okay. A equal to 1. A equal to 1. So label is nothing like just like tagging it with some name. Okay. You can think of it as a key value pair and you are tagging that particular container with some name. Okay. It is just like that. And now this service will have a label selector. Okay, this service will have a label selector which will also which will have a label selector of A equal to 1. Okay, so now what will happen? So when I'm saying A equal to 1, is A equal to 1 is nothing but your label selector. Okay, what is this thing? Is label selector. So what happens? So why we are going ahead with labels and not the IPs? So as I mentioned, each pod will have its own IP. This is one pod, this is one pod, so it is P1, this is P2, this is second pod.
Hey viewers, are you looking for formal training on SRE practices? Take our SRE program. This course will teach you how to successfully implement site reliability engineering in the modern day 24/7 services. Kickstart your SRE training today. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Okay, this is P3, that is third pod, and this is P4, that is fourth pod. Okay. So what happens? So as I mentioned, every pod will have its own IP. But then why we are not using the IP, but we are using the labels? So the reason is simple. When one pod restarts, it will come up with some new IP. And if we assign the service some IPs, then it won't be able to reach the backend pod because the IPs change. So in this environment, the Kubernetes will definitely restart some pods, or there might be some there might be some restart happening at the pod level, and then pod will come up with some new IP, and we don't want that to happen. So service is nothing but an abstraction layer that have some IP, okay, that have some IP but does not have the network interface. So it is just like a virtual IP that we are giving to this service. And now it uses label selector. So that means when I am giving this a equal to 1 as a label selector, so it will select all those pods those are having the same labels. I mean, in the backend, if all there are 50 pods, those are having a equal to 1, so this service will load balance that 50 pods automatically. Okay, and this all those pods should have this particular label. So service load balances the pod. Okay, and service is nothing but a network component used to communicate with the external world. Okay, so what is service? Service is nothing but the abstraction layer, or I would add some new word here, that is network abstraction network layer. And what is the abstraction? That means it have the virtual IP. Okay, and it is required to load balance the pod. So it load balances the pod and traffic. Okay, it load balances the pod, load balances the traffic to the pods. Okay, so service is nothing but an abstraction layer, virtual IP network layer required to load balance the traffic to the pods. And service don't have physical interface, will carry the IP address. And the next thing that we discussed here, is service uses label selector to load balance the pod, the backend pods. Okay, so we'll all see this in details, but for now, so this is what the basic thing is. But now let's go ahead and understanding the basic Kubernetes concepts here. So we have learned about the service, we have learned about the pod, we have learned about what is a node. So basic overview we have right now, and we'll discuss more in the coming section. Okay, so now we have already learned about Kubernetes service. Now the other concept is Kubernetes networking. So how does this Kubernetes networking happen? So Kubernetes uses the container network interface, which is called as CNI, and there are lots of overlay networks that we'll be seeing once we go ahead. So basically for now you can think of it uses some kind of external plugins, and by using that you can configure your complete networking, like how one pod should be able to talk with another pod, if you want some isolation or between the different projects, and also that is also possible. Now next concept is persistent storage in Kubernetes. So what is persistent storage? So just like you can think of it as when you connect some NFS server or you connect some storage to your virtual machines, similar to that, you can also provide some storage to your pods. So pods is nothing but a container or a set of container, and for that particular container, you can attach some uh, storage. So that is a persistent storage. We'll be seeing it in later section. In this particular slide, I just want to throw some lights on different concepts. So service we have understood. After that, namespace, labels, and annotation. So what is namespace? So namespace is nothing but you can think of it as a project. So let's say there is a developer 1 and there is a developer 2. Now let's say this developer 1 is working on project 1 and developer 2 is working on project 2. So I want that developer 1 should not be able to see what developer 2 is doing, or developer 2 should not be able to see what developer 1 is doing. So for isolation purposes, we create the namespace. So what is the namespace? What is the namespace? So persistent storage. So it is like, just like think of it as a storage providing external storage to your pod. And the next thing here is that we are seeing here is networking. So how networking works? It Kubernetes uses the container runtime uh, container network interface using the plugins like Flannel. Okay, so we'll see this in later section, like what is the Flannel and why. So for now, just understand that Kubernetes uses some container network interface, okay, for communication between the pods and all, okay. And after that, what we are seeing here is namespace. So what is namespace? Namespace isolation. So we are just using names for isolation, okay. Isolation of projects, or namespace you can say like project used for isolation of pods, okay. So inside namespace we run different pods, okay. So for isolating that particular pod, you can use the namespace. After that, labels we have seen, annotations is similar to labels only. The label is a like key value pair that we are using here, okay. And annotation is nothing like just like that only. The label you can give the annotation. So once we see that pod YAML, no, you will get that what I'm saying. So yeah, so this is the basic concepts of your Kubernetes. So let's now understand what happens when you spawn up the container inside your pod. Sorry, when you spawn up the pod inside your Kubernetes cluster. So what happens? So as I mentioned, the last thing, the last layer, what you are seeing here is the last layer that you are seeing here is a namespace. So what I am saying, namespace is nothing but just like a project to isolate the pods, right? So pod will run inside your namespace. So that's what I mentioned. So this namespace is the last.
Thanks for watching. Want to study further? Join our training programs today.